So here's part B of problem 6 from the 2012 AB exam. And I have something on the screen already here, and that's something that we did in part A in a previous video. It's a sign chart for our velocity function. We used it to say that the object was moving to the right from 0 to 3, to the left from 3 to 9, and to the right from 9 to 12. That'll help us a little bit here in part B. And what part B says to do is write but do not evaluate an integral expression that gives the total distance traveled by the particle from 0 to 6. Now the reason why I want to refer to this a little bit is because from 0 to 3 the object travels to the right. So the object's traveling to the right. And then from 3 to 6, because the velocity is now negative, the object is going to be traveling back to the left. We want total distance traveled here. We don't just want change in position. If we wanted change in position, all we would have to do is integrate the rate of change of position, which is velocity, from 0 to 6. The change in position is going to be found by letting the integral do all the work. Anything that's supposed to come back positive does come back positive. Anything that's supposed to come back negative does come back negative. And at the end of it, we have our total change in position from 0 to 6. We want total distance traveled here. So we don't want any of our distances to come back as negative as computed by the signed area that an integral gives us. So what we need to do is we need to change the sign of any velocities that are negative. And the easiest way to do that is to just slap absolute values around your velocity. So this would actually be the integral of speed from 0 to 6. And if we integrate speed from 0 to 6, speed is always positive. It's the absolute value of velocity. None of our values on the graph of the absolute value of v are going to be negative. It's going to just accumulate distance rather than add on stuff that's in the positive direction and subtract off stuff that's in the negative direction. So this would be the expression that will get us the total distance traveled.